Alright, here we go, guys. Standardized test practice. Number 4, again on page 201, but you have the worksheet handed out to you. So the question reads, a moon revolves around a planet with a speed of 9.0 times 10 to the third meters per second. So that's going to be our velocities, 9.0 times 10 to the third meters per second. The distance from the moon to the center of the planet is 5.43 times 10 to the 6th meters. So it's going to be our radius is 5. It's not a 5, that's a 4. 5.43 times 10 to the 6 meters. No conversion necessary because we're all in meters. What is the orbital period of the moon? Alright, so if we take a look at our two equations here, it's asking for our orbital period, which is our t. But in order to determine our orbital period, we need the radius, which we have, but we also need the mass of the planet. And so we don't have the mass of the planet yet. So we can't solve an equation with two unknowns. So we're going to have to go down here to our orbital velocity equation. We have the orbital velocity, we're given that, and we're also given the radius. And so the only unknown in this equation is the mass of our planet. And so we can solve for the mass of the planet here, and then insert that up into our equation for orbital period, and that will allow us to answer this question. Alright, so first of all I'm going to solve for the mass of the planet here before I insert my numbers. So I'm going to square both sides. V squared equals G mass of the planet over R, multiplied by R, V squared R, and divide by G, divided by G, equals the mass of our planet. And we're going to plug in our values. That's going to be 9.0 times 10 to the third. That's meters per second. That whole value is squared. My R is 5.43 times 10 to the 6th meters, and this is all divided by G, which if I remember correctly, I'm getting kind of sick of it, 6.67 times 10 to the negative 11th Newton meters squared per kilogram, and this is all going to tell us the mass of this planet. Alright, I'm going to pause here and do some calculating. Alright, so the mass of our planet following these calculations comes out to be 6.594 times 10 to 24th. That's going to be in kilograms. Alright. So what we need to do is use our period formula now. With all this information that we've been given. Let's see if I can remember what this is. Period equals 2 pi square root R cubed over G times the mass of the planet. Is that correct? Good. Now we just got to plug in. So 2 pi square root, our radius was 5.43 times 10 to the 6th. So that's going to be 5.43 times 10 to the 6th, and that's meters. That's going to be to the third power divided by 6.67 times 10 to the negative 11th Newton meters squared per kilogram times 5 point. That's not true. Times the mass of our planet, which is 6.59 times 10 to the 24th. That's kilograms. I'm not going to put the units there just because I'm running out of space. Now again, we'll go ahead and pause for calculation. Alright, so after fighting with my calculator a little bit, we've decided that the period of this moon, around this planet is I got 1, 2, 0, 7. This is going to be seconds. This is all in seconds. So, and then also times pi. I did not include the pi. And so if you look at the choices, they're all in scientific notation. So if I were to put this into scientific notation, it would be 1.2 times 10 to the third times pi, which can be written as 1.2 pi times 10 to the third, which is choice C. Hooray. Alright guys, see you at number 5.